Worldwide, there are more deaths due to surgical complications than HIV, malaria, and tuberculosis combined. One way to reduce surgical complications is to use minimally invasive surgery, such as laparoscopic surgery. However, 90% of patients in low and middle income countries lack access to laparoscopic surgery. So our team developed a low-cost reusable laparoscope called the KeyScope to increase access to laparoscopic surgery. So Annie's just going to plug this in. This is all our device requires, just a simple USB. The camera and the light source are right there at the tip of the probe. So all of the magic of this device is in that last half inch. And then the rest of this is actually just wires that are connected to a circuit board inside the handle design. Laparoscopes are really expensive. It costs over $130,000 to outfit a single operating room with a laparoscopic tower and associated equipment. In comparison, our KeyScope can be built for about $1,000, so we're decreasing costs by an order of magnitude. So the design considerations were that it needed to be low cost, but to still have the image quality on par with the standard of care device. The most challenging thing was to make sure that the small LEDs were generating enough light to illuminate the entire abdominal cavity so the surgeon could see all of the organs that they need to during surgery. Through partnering with the engineers at the Fischel Institute for Biomedical Devices, we were able to figure out a way to increase the brightness that is seen by the camera without increasing the heat that's generated at the tip of the device. Okay, so Annie has the camera pulled up here. I'm imaging Annie. And we're going to insert this into the portable testing chamber. And now you can see that resolution target on the screen. Bench testing showed that our KeyScope actually gets finer resolution than the standard of care system. And what that allows the surgeon to do is see smaller features in the abdomen. So small blood vessels, they can see better with our device compared to a commercial system. We have some amazing partners in Uganda who have been working on this project alongside us. And we're working with a contract manufacturer, and they are actually starting to prepare for manufacturing of the devices locally. And now we're getting ready for our first in-human clinical trial at the Ugandan Cancer Institute in Kampala. We're going to be using the KeyScope to guide biopsy, which is one of the simplest laparoscopic procedures that you can do. We've specifically designed this device for LMICs, but we think that it could have a place in US markets as well, particularly in rural communities that also lack access to sophisticated technologies. I hope that ultimately we're able to reduce surgical morbidity and mortality for people in LMICs. The World Health Organization estimates that there's over 200 million surgeries performed every year, and only 15 million are being performed laparoscopically. So there's a huge potential for increasing access to laparoscopic surgery, and I hope that the KeyScope can do that.